All right, so we're continuing with our extra practice trigonometry solutions, and we in the last video where we worked through these first three here. We also did a few others, but we stopped at 5C, so we'll see if we can finish up these next couple of columns here in this one. We might even get to number 6. All right, so let's take a look here. The first one is the inverse sine of 2. So let's take a look at that. And so 5D, inverse sine of 2. Remember, that's equal to an angle theta such that the sine of theta is equal to 2, right? That's a problem, right? Because the sine function, we know no matter what we put into the sine, is always between plus or minus 1. So therefore, there is no angle theta such that the sine of the angle is equal to 2. And so therefore, the answer does not exist. Good, so the inverse sine of 2 is not computable using our definitions. E, the inverse tangent of minus the square root of 3. Good. Now, the inverse tangent is sine over cosine. Or, sorry, let me rewrite that. The inverse tangent of this minus the square root of 3 is equal to an angle theta such that the tangent of theta is minus the square root of 3. And so that's where we have sine over cosine equals minus the square root of 3, right? And so, once we've done these a few times, you'll notice that that's going to be where the tangent of theta is actually going to be minus in the front and then square root of 3 over 2 divided by 1 over 2, right? Sine over cosine. And so what does that represent? My pi's or the angles are looking the same now. Let's see, pi over 6 is 1, 2, square root of 3. So the tangent is, for the sine function then to be square root of 3 over 2, we need that angle to be pi over 3. So where is the tangent function? Whoops, no, that's a terrible circle. God. Where's the tangent function negative? Well, because this is sine over cosine, either the sine or the cosine should be negative, but not both. So that means we're over in this quadrant, over in this quadrant, right? And so if we need the angle to be pi over 3, so here's our pi over 3, we'll just flip it over here. So that's going to be 2 pi over 3 is one angle where the tangent is going to be minus the square root of 3. And then this one down here is 2 pi minus pi over 3. What's that going to be? 2 pi, we'll just do a little calculation. 2 pi minus pi over 3. So that's 6. Is that 5 pi over 3? And so our solutions then are going to be 2 pi over 3. Oh, I should say, or 5 pi over 3. I should say this is where the inverse tangent is. We're computing the inverse tangent function. So are we going to have two solutions? Which one does your computer figure out for the inverse tangent? Well, the inverse tangent, or I should say the tangent function, how is that going to be restricted so that it has an inverse? Here's the tangent function. Yeah, normally we would just take, this first piece here and use this for the inverse tangent. And this is going from minus pi over 2 to pi over 2. And so we're only going to be taking angles here. And so we're not going to use 2 pi over 3 then. We're going to be using minus pi over 3, minus pi over 3, or you could say 5 pi over 3 too. That's fine. Well, since we're labeling this as minus pi over 3, let's not use that label. We'll use that label. Good. Good, so that one had a little wrinkle there at the end. Let's see, our next one is just the, I guess I made a typo there. That's true. The inverse tangent of 1 is equal to an angle measure such that the tangent of theta equals 1. So that's sine equals cosine, or the x-coordinate of the unit circle is equal to the y-coordinate of the unit circle, which is there or there. So that's pi over 4, and then this would be 2, 3, 4, 5 pi over 4. But do we want both answers? No, we only want the answers that are between plus pi over 2 and minus pi over 2. And so that means that pi over 4 is our only answer. Good. Let's see, that's h is next. Inverse secant of minus 2 is theta, where secant theta is minus 2, and that's 1 over cosine theta is minus 2, or cosine of theta is minus 1/2. Good. Now that's our x-coordinate, right? Where is the x-coordinate negative on the unit circle? Whoops. Well, it's here, right? But we said in our previous discussion that for the cosine, we're going to only consider angles between 0 and pi. So on the unit circle, that's only these angles. Okay, and so if our x-coordinate is negative, that forces us to be here, right? And so if the cosine is minus 1/2, then we probably remember, right, from the other ones, that the y-coordinate is going to be the square root of 3 over 2. And that's going to be 2 pi over 3. So theta is 2 pi over 3. Good. All right. How are we doing with these? Are we just about done? I is the inverse secant of 2 over the square root of 3. Okay, we probably see where this is going. This is where the cosine of theta is square root of 3 over 2. And so if you just want to use the circle or the triangle, don't I have one up here? Good. Where's the cosine equal to the square root of 3 over 2? Theta is pi over 6. And again, in this case, we only have one answer, right? Very good. Okay, we finished off number 5 now. Let's see, we're at about 7 minutes. I think we have time to, maybe I'll stop here. And we'll go ahead and start a new video for the next section, because what we want to do is we want to think about functions and their inverses together, f composed with f inverse of x, or f inverse composed with f of x. And so you remember that this is equal to x because the functions and their inverses cancel each other. But you have to be careful that you're in the right domain. So that's what we're going to be discussing in the next video. Okay, see you then.